Okay, I guess I will just start. So it is my pleasure today to present to you the SPHN SHACLer, which is a tool that we have built to automatically generate SHACL rules based on the SPHN RDF schema. And before going into the details, I would like to give you a bit of the overall vision of our project. So we are part of the Swiss Personalized Health Network, so that stands for SPHN. It's a national initiative that aims to bring clinical routine data, but also other kinds of health-related data from the different data providers, so university hospitals mainly, to research. And this is actually in a way that the data is being integrated and in a fair manner, so findable, accessible, interoperable, and reusable. And in order to achieve that, we have built the SPHN Semantic Interoperability Framework, which is heavily based on the semantic web technologies. And I would guide you through this whole framework that you see now, one by one. So first, we have a big focus on the semantics, so how things need to be defined. And this is basically represented in the SPHN dataset. Yeah, you can see that we have a specific concept here, which is called birth, and we associate all the metadata that connects to it and represent these concepts. This is defined in an Excel sheet, and from this Excel sheet, we derive an SPHN RDF schema, which is basically the blueprint of how the data must be represented in the end. So it tells you in this example that you have a birth class which is being defined. It contains certain properties associated to it, and these properties may link to other classes we define, or also it reuses some of external standard terminologies that I will tackle just after. In the SPHN project, we have SPHN schema, but we also have researchers and their project coming into play who say, hey, I need to have this kind of data represented. How do I model that in SPHN? So they have the means to extend the SPHN dataset and therefore the SPHN RDF schema to integrate also their semantics. And we have a process where when these concepts become more mature enough, we then integrate that into SPHN. So it's an iterative process where things get built up over time. And we usually have 1 releases per year of the SPHN RDF schema. And in order to facilitate this whole transformation from the dataset to the RDF, we have built the SPHN Schema Forge, which basically builds the RDF schema. But not only. If you can see, we also have validation rules using SHACLs mainly, which will be the core of the talk today. We also generate some statistical queries, which will enable to query for information about the data. But we also have an HTML documentation, which is basically a more human-readable representation of the RDF schema. So it's based on Pylode, just for a bit of information on it. Then once you have all this bundle, whether it's a SPHN RDF schema or a project-specific RDF schema, this can be given to the data providers, so mainly here the hospitals, for instance, who will take this bundle and will deliver data according to these schema. So we have built the SPHN connector, which enables to take data from clinical warehouses, and it ingests all this data, can do some de-identification tasks, transform the data in RDF, and then also validates to the SHACL rules that we have built previously. And once all this is done, RDF data files are generated, which is then shared with the researchers in a secure environment so that they can build their knowledge graph and then do their analysis. One last part I would like to highlight in this framework is the SPHN terminology service. So this is actually for generating RDF versions of external standard terminologies that we are reusing in our schema, so that basically for representing specific value sets, we try as much as possible to reuse existing standards and not generate our own variables or individuals in the schema. So now to the core of the presentation today, I would like to present the SHACLer. So this is a Python-based script which builds SHACL rules automatically from the SPHN or project RDF schema. This is actually integrated in the Schema Forge. So if you remember, the schema forge was taking in the Excel, the semantics, building an RDF schema, and from this RDF schema, actually the SHACLers come into play to generate the SHACL rules. And this is actually an important step for us because we have many stakeholders that are involved in the project, and it doesn't suffice to just provide them a schema and say, hey, provide data according to the schema. We realized that there are still data not fitting to the schema, so we needed to have one single point of truth where people could check and validate the data according to the schema we have. So in the SHACL that we generate, we have different levels of severity that are considered. So we have first the errors, which are basically, if you have an error, you have to fix it, otherwise your data is not valid. So this concerns violations of the schema definition. So we have cardinality definitions, we have specific value sets that can be used in particular contexts. So you need to fit to these restrictions. We also have added an error check for date times. So you need to make sure that a start date time is actually happening before an end date time in a particular context. And you do see data where this error raises, so it's good to have it. Then the second level of severity that we have are the warnings. So in this case, it doesn't mean your data is necessarily wrong, but you may want to check it because there could be something wrong. This concerns basically instances which are violating our naming conventions. So we do have naming conventions for our concepts and their instances, but they are not, let's say, mandatory to be followed. In the SPHN connector, for instance, we do use those naming conventions. So if you use the SPHN connector, you would not get such warnings. We also have warnings for unversioned code. So this is about the external terminologies that we are integrated. Some of these external terminologies have versioned. We do integrate different versions of those terminologies, and we are able to see if a specific code of a terminology had a change in the meaning. Let's say if I take a terminology code in 2014, and the same code in 2017 may have changed. But if you're providing data with this code without telling which version it actually corresponds to, there might be an issue with what was the intended meaning of that code. So we are checking for these ones as well, or providing means to check these. Then the last level of severity are the information. So this is really, it's okay if, it's really providing you some informational insight about your data. Still, it is about the external terminologies that are being used. So if you have an old version code provided in your data and it is still valid in the latest version, then it will tell you, hey, you're using an old version code, but it's still available in the newest one, so all good. If you're using an old version code, but it's not present anymore in the latest version, it will raise you this information, and you would know that, okay, maybe in the future you'll need to be careful about this one. So about our SHACLs, we do have two ways of representing them. So in the SPHN RDF schema, the shapes are open because we enable this extension by the projects to add their own concepts or to extend our SPHN classes and properties. So the SPHN ones remain open, but the project-specific shapes are closed. So the truth only lies in the project within that space, although for SPHN, this can be extended. And as I probably mentioned already before, the projects are free to extend the SHACLs by adding those new classes and properties they need for their study, but they can also add more finer rules, which are not necessarily the ones generated by the SHACLer, but something maybe more manual to check for, let's say, clinical relevant statements or values. So now we'll go a bit more into the details of the actual SHACL rules that we have built. We have not seen so far any of these coded statements, but I hope this is maybe one of the crowd where I can have such slide, and most of you would probably understand it. So we do have cardinality constraints that are implemented. So in our schema, we do have information about minimum and maximum amount of predicates one instance can have. And in this example, you can see that the biobank sample can have or must have at least one sample, but it can only have one at most. And if you see the example on the left side, this would be validated, while the one on the right side, which has 2 samples, will throw an error. Then we have also class constraints. So when we have, for certain classes, we have specific value sets that are allowed. And in these cases, we use these class constraints. So in this example of the substance, it can have a code that either comes from the SPHN code or from ATC, which is for a terminology for drugs. And then you also have SNOMED CT. So in the case of substance, you can only allow any code coming from the substance and all the children of this substance class. Therefore, here in the example on the left side, you can see that the ketamine actually comes from the substance hierarchy, and therefore this would be valid, but this lacking code actually would not be validated because it does not come from this from this class. And talking about these hierarchical information, there are a few cases in SPHN where we have a code, but we don't allow the subclasses of the codes as possible value. And in order to cope with that, we have added what is called a SCOSCOP note to say, okay, the subclasses are not allowed in this case. And this gets interpreted with the SHACLer as the following. So you get a sparkle constraint that gets added into the SHACL rule, which will state, okay, these values are allowed and possible, but do not enable any of the subclasses of these ones. Sequence path constraints. So we had in the first talk this morning a statement that paths were not important in graphs. Well, we do use them, and they are quite important for us because this enables us to restrain or restrict statements in a contextualized setting. So in this example here, we have an hour restriction on the age class, where the units can only be hour, week, year, day, month, or minute. And the unit is actually used in other contexts, but they do not have restriction. They do not necessarily have these restrictions. So in order to represent or validate the data for age, we do use this SH path to actually specify, okay, if you have an age class and you follow this path of has quantity, has unit, has code, it must only have these values. This is a bit of a more complex one, or a verbose one, but in this case, we check if an old version code, which is being used and which was valid, is actually not valid anymore. And you would see that we have actually a statement being added to our versioned terminologies, which checks if there is a meaning validity in the current version. And then you get a Boolean value which tells you whether it's true or false. And in this case, it would be false, so it will throw you an information in the validation report. So these are all, let's say, some of the examples that we have implemented, but how is that actually useful? So, well, the SHACLs are being put into the settings of the SPHN connector, so anyone who uses the SPHN connector pipeline can check whether their RDF data fits and complies with the schema and also to the other rules that we have implemented. And they also have actually the possibility to filter for different levels of the SHACL rules. So they can say, hey, I'm only interested in the errors, the warnings, and the info I don't care, so you can filter out this, and then your pipeline will most likely run faster. We actually also got some data from one of the hospitals who tested the connector with 270,000 patients, which actually had 63,000 of them had violations, and the whole pipeline, in the whole pipeline, 1/3 of the time was actually spent on validation. So you could see that it's quite consequent, and it needs time to do the validation. But this is something we are trying to see how we could improve with either fitting the rules, or trying to see if there are ways to improve these performances. So we did, or we are actually doing a benchmark on how the different checks perform. So this is an example with 100 mock patients where we did check, okay, what was the runtime for structural checks, syntactic checks, and terminology checks. And you can see that our structural checks actually are basically leading to errors, and they are quite quick to run. This is most likely due to the fact that the structural checks are basically going through the patient file, so the patient RDF file, which is in the order of megabytes, and it doesn't do fancy stuff. It just checks, okay, are the cardinalities compliant? Are the ranges compliant also for this specific property? So this would be quite quick. Then we have the syntactic check, which are a bit more time consuming, and these actually corresponds to some of our warnings. And here it takes a bit more time because you do have a string regex search that would check whether it fits to the regex. And finally, we have the terminology check, as you can see, is quite exploding the performance. So these are basically the information that we get from our SHACL rules. And this is most likely due to the fact that the files are actually quite huge. So when we talk about these external terminologies, they are not in the order of megabytes, but probably gigabyte files. So going through all these files would be quite consequent. Yes. With that, I mean, I come to the conclusion that in SPHN we have implemented some SHACL checks, so to check that the data is compliant with the SPHN or the project RDF schema. We check the compliance with naming conventions and validity of codes that are being used from external terminologies. But what we do not do yet, maybe we will think about it, but is really to check clinical correctness. And currently this is led up to the project to do so. So if, let's say, a project, I don't know, I'm taking an example of a pediatric project, they may not be interested in patients who are above 18 years old, so they would be maybe putting a SHACL rule that says, hey, if you have a data point with a patient about this age range, then throw an error and I don't need it. So we hope that with these validation steps, we have helped the projects and also the data providers to increase the quality of the data and fit actually to, so that they can also fit to our schema. But yeah, I think, I mean, there's this statement that, you know, you have PhD students or curators that spend a lot of time manually validating the data. So the hope is that this actually gets reduced, and hopefully at some point we don't even need them to spend that much time doing this. With that, I would like to thank all the collaborators and my colleagues, and especially Deepak Uni, Sabine Ursule, and Philip Kraus, who are also in this room. Not Philip Kraus, actually. Yeah, who are also heavily involved in this work. And thank you for your attention.
Thanks for the presentation. Looks really interesting. So I'm not an expert in semantics at all. So, and I read the title of your presentation. It says automatic generation of SHACL rules, and I have not listened carefully. So where is the automation comes from? And if, just as follow-up question then as well, what are the ways of enabling business users to write something like SHACL rules without knowing SHACL necessarily syntax and so forth? Are there any tools available for visual representation of those and so forth? Thanks.
Thank you. So for the first question, the automatization comes with the fact that we are relying on our RDF schema to build those SHACL rules. So everything you find in the SHACL rules are actually defined somehow in the schema. So we do have these restrictions that are added in the schema that say, hey, for this class, this property, these are the cardinalities that applies, and then this gets translated. And that's why we also have these sometimes, let's say, hacked information like the scope note, which gets interpreted into some statements with the SHACL. So, and the SHACLer is actually the tool. So the Python script is basically technically doing the work. Like it checks, okay, what does the schema provides, interpret the schema as such, and then build the SHACL rules. Can you repeat your second question? The business model, is there anything that exists that enables to build SHACL rules without having to know about SHACL rules?
Yeah, exactly. Yeah. So I mean, you partly answered it with the Python script. You can do it if you define your ontology in the first place. But what about those more complex rules that you've shown? For example, there's involved some SPARQL queries and so forth. So maybe there is any way of user interface or something that helps with that?
Well, you do have libraries you could use. So in our case, we used RDF lib, this Python library. But if you really want to go into those more technical definitions of SPARQL constraints and so on, you really need to know, I think, how to build them. I'm not sure if there are tools that automatically do it. I'm not aware of it. Maybe someone knows in the room, but I'm not aware of that. So we have been actually having experts doing that and knowing what a SHACL looks like, what are the different constraints and shapes we can use and for which purposes. And we also realized that there are some things we could also improve because, you know, we also learn on by doing them. So yeah, I don't know other.
Hi, Vasundra, I love your talk. Do you think that you could enrich those SHACL shapes with pointers to the visualization as in the previous presentations? Do you think there could be space for expanding there?
Which visualization?
Like, this is a patient, so visualize a patient record. This is a meeting, make an agenda, or not?
I'm not sure I understand. No, please, can you repeat?
As in, some concepts have possibilities of being represented in some ways, that you kind of add that to the...
To the SHACL rules, you mean?
Yeah.
That's a good question. I'm not sure. I'm not sure I know how to do that one. Yeah. I mean, we do have the restrictions that tells you, okay, for this specific concept or class, these are the things that apply. But then you want to say for the data instances, how we should. Okay, we can take it maybe offline because I'm not sure I understand where you want to go with this one. Okay.
Perfect, that seems to be it.
Thank you.
Thank you, Anna.
Thank you.
Thanks. So there was, I really like this project. There was a very good presentation by Sabine. No, actually, was it you, Sabine, or was it? The one at the Linked Data meetup. Oh yeah, you did it together, yeah. Unfortunately, I think you spoke German, right? Yeah. So I wanted... Yeah, I know, it was Swiss government. But it was a really, really good presentation where you get the high-level overview. It's a super cool project. Maybe I will link to it when they publish it for those who understand German, because it gives more context about what the project is about. And the approach is super, super interesting because it has to work with decentralized data owners, which are very, very careful by definition, and they have to be about their own data. So it's a super interesting setup. And the other presentation they did at the Linked Data meetup from the Swiss government showed a bit more from the high-level perspective.